Okay, so in this video we're going to look at how to find the rate of return given a set of cash flows, which is also a time value of money issue. So here's our problem. If you loan a friend $200 today and he promises to give you $5 every 6 months for 4 years, and he will pay you $250 at the end of the 4 years, what nominal annual rate of return will you receive on your loan? So if we think about this, we have $200 that you're loaning your friend today, which would be an outflow of cash. Then he's going to give you $5 every 6 months, so that's $5 of inflow every 6 months for 4 years. Then he's going to give you $250 at the end of the 4 years, and we need to find out what the nominal annual rate of return will be on the loan. So if you go to your time value of money solver, then we're going to have the standard set of inputs. Alright, so in this case, as always, NI and payment have to connect to the same period of time. So note that he's giving you $5 every 6 months. So if he's giving us $5 every 6 months, then in that case, we're going to put $5 here for the payment because it's the same amount, $5, every 6 months for the 4-year period. So that qualifies as an annuity. Now, if we're doing a payment per 6-month period, then N needs to be the number of 6-month periods. So how many 6-month periods are there in 4 years? Well, there are 2 6-month periods per year, and there are 4 years. So we're going to have 4 years times 2 periods per year, and that will give us a total of 8 periods. I, the interest rate, is what we're trying to find. Present value would be what happens today. So in this case, you're loaning your friend $200 today. So if you're loaning your friend $200 today, that's going to be negative $200 because it's going to be a cash outflow for you. And then he's giving you the $5 per 6 months, and we're giving that a positive sign because that's a cash inflow for you. And then at the end, he's giving you $250. So that's going to be our future value because it happens at the end of the 4 years, and it's positive because it's a cash inflow. So that gives us $250 for our future value. So it's not made quite explicitly clear, but he is saying that he's giving us $5 every 6 months. So most likely, without any information to the contrary, since we aren't dealing with any kind of odd scenario like rent or something like that, we're going to assume that this is an ordinary annuity, so our type should be set on end. So in that case, you should solve for the rate. So I'll give you a moment, if you can pause the video, to find the rate that you get. Okay, so if you tried that on your calculator, what you should have gotten is a rate of 5.10795. So 5.10795, and I'm hanging on to a couple extra decimal places here, probably more than necessary, but we'll round off at the end here. So let's think about this though. The problem is asking you for the nominal annual rate of return on the loan, but notice that N was the number of semi-annual periods, and the payment was $5 per semi-annual period, so per 6 months. There are 2 6-month periods in a year. So that means that this interest rate that I've gotten is the interest rate per semi-annual period. Since the problem is asking for the nominal annual rate, all we need to do is double this in order to get the actual answer. So if we take the 5.10795 and multiply by 2, and I'll give you a moment to work that out. Okay, so if you pause the video, or perhaps worked fast, then what you should have gotten was a rate of 10.22%. So that would be our nominal annual rate of return received on this loan to your friend. Now, we could also try solving this in Excel. Alright, so if we're going to try this in Excel, the formula that we're going to need is equals rate open parentheses, and it asks for the number of periods first. And the number of periods is going to be 4 times 2. And then it asks for the payment, which in this case is 5, as we have established. Then it asks for the present value, which in this case is negative 200, because that is the cash outlay today. Then we have an optional argument for future value, but we do have a future value, which is 250. So we would put in the 250. And then there are optional arguments for the type of payment, whether it's beginning or end. So in other words, for the annuity aspect of these interest payments. And you can also add in a guess for the interest rate if you want to help Excel out. But we don't need to do either of those two optional numbers. And so if you try that out, what you'll get is, lo and behold, 5.10795, which of course then we would need to double in order to get the annual rate of 10.22%, which is the answer. I recommend you consider trying some similar problems and see how you do.